Good evening. I wonder if you've noticed these stars arranged in a group. They're in the southern part of the sky at the moment, rather high up, and they're quite easy to identify. And they make up the star cluster which we call the Seven Sisters, or the Pleiades. Well, just in case anyone is in trouble with identifying the Pleiades, we can always go back to our old friend, the constellation of Orion, which is certainly the most splendid constellation visible, I think, from the British Isles. You'll recognize the two main stars in the eastern part of the sky at the moment, Betelgeuse, the red one, and Rigel, the brilliant white sun, equal to 20,000 of our suns, in the lower right-hand corner of Orion. And you'll also notice those three stars which make up the Hunter's Belt, almost midway between Betelgeuse and Rigel. If you use those as direction pointers and carry a line upwards in the sky, then you will come to yet another orange-red star, Aldebaran, the Eye of the Bull. It's slightly fainter than Betelgeuse and much the same color. And then if you carry on that line and bend it slightly downwards, then you will come to the Pleiades. Well, I'm rather afraid that people who live in cities and towns won't have a very good view of the Pleiades, because they do tend to be drowned by any artificial lights which are around. And, well, I was in London the other night, and the sky was quite clear, and I had a look for the Pleiades, and, well, I could see them, but only as a very faint nebulous haze, and I think because I knew where they were. But then if you go out into the country, where the skies are really clear and dark, then you will not only see the Pleiades very prominently without a telescope, but if you look, you will see that they're not made up of luminous haze at all. They are made up of individual, separate stars, and it's interesting to see how many stars you can count. I'll come to that in a minute or two. In fact, if you've got any kind of a small telescope and you turn it towards the cluster, a great many of the stars come into view. And we now know, by means of photographs taken with very large telescopes, that the whole cluster includes something like 250 members. So it really is a kind of independent star system within our own galaxy. It's what's known as an open or loose cluster, and it's much the most conspicuous of them. The stars in a cluster of this kind move through space as a kind of independent unit, and they remain at very much the same distances from each other, and they move through space together. But of course they do share in the general rotation of our galaxy. Now, we've found out in recent years, largely by the use of radio astronomy, that our galaxy is a star system made up of something like 100,000 million stars, of which of course the sun is one. Now, we've got a model of it here, and we're imagining that we're looking at the galaxy from an edge-on view, so that it gives the general appearance of a kind of poached egg. But in fact, that middle nucleus, which you can see there, which does look a bit solid, in the real galaxy, that's made up of individual stars together with gas and dust. Well, now let's imagine that we're going to see the galaxy face on. When we do that, we'll get the general impression of a vast Catherine wheel. And we can see various other galaxies in the sky which do give that appearance. Now, there we have the nucleus again, and you can see the spiral arms. Our own very insignificant sun is some way out from the nucleus. It's well out towards the edge. There it is. You can see it on the edge of the pointer. Now, we've also found out that the galaxy is in a state of rotation. It's going round very much as a Catherine wheel does, but of course on a very different scale. The sun's going round the center of the galaxy in the same way as all the other stars, but it takes something like 225 million years to make one complete journey, and that time is sometimes known as the cosmic year. Now, the star clusters, the loose clusters such as the Pleiades, are going round the center of the galaxy in the same way that the sun is, but they're doing it in company. But they won't remain as star clusters forever, because as they go round, they're being subjected to various influences. They're being pulled on, for example, by the great mass of material in the middle of the galaxy. And then there are various wandering or stray stars, if you like, and these stray stars may pass through an open cluster or go quite close to it and pull upon some of the stars in the cluster. Now, the result of all these disrupting influences is that after only one or two journeys round the center of the galaxy, we believe that an open cluster loses its identity. Its stars get split up and they separate, and the cluster ceases to exist as a cluster. But of course, this breaking up of a loose cluster is a very, very slow process on our everyday standards, and certainly clusters such as the Pleiades have been familiar features of our night sky ever since, well, certainly ever since men appeared on the Earth. And there are some fascinating old legends about them. I think the one that I like best comes from the Red Indians. And according to the Red Indians, the seven sisters, the Pleiades, they were once children. And these children liked to wander about the sky among the stars. And once, when they were doing that, they got lost, and they couldn't find their way home. And so they huddled together so that they shouldn't lose each other. And now we see them there as the Pleiades. Well, that's a charming old legend, I think. But of course, nowadays, we've been able to study the various stars in the Pleiades with complicated instruments, and we found out a great deal about them. We know, for example, that the main stars in the Pleiades are very hot and rather blue. They're what we call blue giants, and they're very much more luminous than the sun. And we also believe that the whole cluster is about 20 light years from side to side. To turn light years into miles, just multiply by 6 million. Also, photographs taken with very large telescopes show that the stars in the Pleiades are surrounded by what looks like shining gas, which is exactly what it is. The shining gas and dust in the star cluster is being illuminated by the stars and is shining by reflection. So it's a really excellent example of what we call a reflection nebula. Well, now, this is where I come to my experiment. Nobody seems quite certain how many separate stars you can see in the Pleiades without optical aid, without using field glasses or a telescope or anything of that kind. Well, I looked it up in various books the other day, and nobody seems to agree. And I made some personal experiments of my own, and, well, it's a very difficult matter. So I thought it would be very well worthwhile finding out. And we can do it if you will help me in this one. Now, I don't want you to imagine that it's an important scientific experiment. Of course it isn't. But it is an interesting point to which the answer has never really been found, and I think this is our chance to do it. So let's find out how many stars can be seen in the main cluster of the Pleiades without using a telescope or any instrument apart from ordinary spectacles if you happen to wear them. So what I'd like you to do is this. Wait until the next clear night, and it must be a clear night. There's no point in doing this when it's cloudy or misty. Then, when the sky is clear and the Pleiades are quite high up, go outside and count how many stars you can definitely see without using any instrumental equipment. Then note down on a postcard the number of stars you've seen, and also make a very brief sketch, which needn't be accurate, but just something to guide me. Then, if you will, put on your name and your address, and just a brief note in 1 or 2 words to say whether there were any artificial lights around when you made your observation. And when you've done that, will you send it to, send it to the Sky at Night, BBC Television Centre, London, West 12. And if we have a kind of mass attack of this kind, then we will, for the first time, find out how many stars can be seen in the Pleiades without a telescope. And when I come to talk next month, I'll tell you the result of this one. I say it's a minor problem, but I think it's worth doing. There's just one point about that, incidentally. I've been fighting my way through an absolute mountain of mail, and I'm afraid I haven't coped with it all. So I'm afraid some people have written to me and haven't had answers as yet. Well, I am doing my best, but it is a tremendous job. I'm afraid that I just can't cope with any more mail during the next few weeks. And so I know you'll understand if I don't acknowledge the postcards about the Pleiades that I very much hope you're going to send me. I'm terribly sorry about it, and I hate not answering letters, but I'm sure you'll understand how I'm placed. Well, we'll await the results of that one, then. But meanwhile, there are other various open or loose clusters that we can see in the sky, and apart from the Pleiades, the best of them is the cluster known as the Hyades. Well, now let's go back again to Orion, Betelgeuse, and Rigel, and the starry belt. Follow the belt upwards, and then we come to Aldebaran, the Eye of the Bull. If you look closely, you will see that extending from Aldebaran in a kind of a V shape, there are some fainter stars. And this makes up the loose cluster of the Hyades. And note that one of the stars there, the one marked theta in the diagram, is double. It's made up of 2 stars very close together. The stars in the Hyades are individually rather brighter than the Seven Sisters, but I don't think they're nearly so beautiful. The reason is partly because the Hyades cluster is much more scattered and it's not so rich. And incidentally, the brightest stars in it appear to be not blue giants, but red supergiants. And since red supergiants are older than the hot blue stars of the Pleiades, we believe that the Hyades round Aldebaran make up an older cluster. But the second reason why the Hyades are not so beautiful is because they are overpowered by the brilliant orange-red light of Aldebaran. And actually, Aldebaran is not a member of the Hyades cluster at all. Now, I'll show you what I mean by that. And I've got a model here which I think will make it quite clear. There's a model of the Hyades star cluster. Now let's bring in Aldebaran. Now, Aldebaran, you might imagine from this, is very close, or indeed inside the star cluster. But now, without moving the model, let's look at it from right angles by using another camera. And you can see straight away that the model Aldebaran is nowhere near the model star cluster. It simply happens to lie in the same direction as seen from the first camera. And it's exactly the same thing with the real Aldebaran and Hyades. Aldebaran, in fact, lies only about halfway between the Hyades and ourselves, so that the Hyades are as far from Aldebaran as we are. It's a line of sight effect, you see. And we have the same thing, too, with the constellations. For example, if we look at the constellation of Orion, well, I've already mentioned Betelgeuse and Rigel. Here's a photograph, but incidentally, Betelgeuse doesn't show up very well because it's an orange-red star and doesn't affect the photographic plate so much. But there it is, and in fact, Betelgeuse is only about half as far away from us as Rigel is. So it's no connection with Rigel at all, and the constellations are just line-of-sight effects. But that doesn't apply to the clusters. And we've various other open clusters, as well as the Seven Sisters and the Hyades. There's Praesepe, or the beehive, in the constellation of the Crab, which you'll see very well in the very late winter and early spring, between Regulus on one side and the twins, Castor and Pollux, on the other. And then we have clusters of an entirely different kind. Here, for example, is the globular cluster in Hercules, which looks like a great sphere of stars. And there's an even larger globular cluster in the southern hemisphere, not visible from here, called Omega Centauri. And if our sun lay in the middle of a globular cluster, well, our night skies would indeed be glorious. These globular clusters are more important than the loose clusters, really, and they form a kind of outer surround to our own galaxy. But unfortunately, they're further away, and only the Hercules one from Britain is visible without a telescope. But still, it's always well worthwhile looking at the loose or open clusters, which are nearer, some of them, and appear, therefore, more conspicuous. And in particular, I do hope that you're going to have a look at the Pleiades and write me these cards and tell me how many stars you can see there without optical aid. And then, if you have got any kind of telescope, well, have a look at the Pleiades, and you'll be astonished at the richness of it. And even a small telescope will give you a superb view of this magnificent cluster of suns. Good night. Evening. We've just had some amazing photographs sent back by the American probe to Mars, Mariner 6. Mariner 7, by the way, has been brought back under control, and we await news from that. But meanwhile, we have this superb series of close-ups from Mariner 6, and I'd like to show you those pictures now, beginning with Mars, as seen by Mariner, from a distance of more than 700,000 miles, which, of course, is a great deal further than the Moon is from the Earth. And even so, you can see there some of the dark areas, which may be vegetation, And at the bottom you can see the white polar cap, which has always been thought to be due to some kind of icy or frosty deposit. So let's go in now to 572,000 miles. And this time you can see there on the left of the center of the picture that V-shaped marking, which is known to astronomers as the Syrtis Major. It used to be called the Hourglass Sea. And just in passing, all these pictures are shown with north at the top and south at the bottom, which is the way the Americans do it. And again there you can see the polar cap. Let's go in now to 463,000 miles, and now the details are starting to be even more distinct. And at the top we can see the polar snows of the northern hemisphere. At the moment it's winter in the southern hemisphere of Mars and summer in the northern hemisphere, and this of course explains why the southern ice cap is so much the larger of the two. Now into just over 200,000 miles, so that when this picture was taken, Mariner was closer to Mars than we are to the moon. And again, you can see the southern cap beautifully, and you can note that the edge of the cap is not hard and sharp. It appears to be rather jagged, and this was something of a surprise. But let's go in still closer to 156,000 miles, and now the dark areas are showing up in all their firmness. And in now to 126,000 miles, and now you can see that the dark areas also haven't got such hard and sharp boundaries as might be thought. But when Mariner went past Mars at only about 2,000 miles, we got the really spectacular pictures. And just look at that. Craters on Mars very similar to those of the moon. And the largest crater on that picture is about 160 miles across. And remember, when Mariner took that picture, it was only about as far from the surface of Mars as we are from Moscow. And I wonder how those craters got there. What are they? Are they due to things hitting Mars, or are they volcanic? I believe myself that most of them are likely to be volcanic, but I remain to be proved wrong. And let me show you now the most spectacular of all these pictures sent back so far by Mariner 6. And just look at that. It's a crater 24 miles in diameter, seen from 2,000 miles. And just to give you an idea of scale, the area covered in that picture is about 63 miles by 48 miles. And I think you'll agree that that crater on Mars is very similar to a crater on the moon. Well, of course, we did know that Mars had craters on it. This had been shown by the previous American probe, Mariner 4, some years ago now. But nobody from Earth has ever actually seen them direct, because Mars is too far away. But all the same, you can see Mars with the naked eye if you want. You can see Mars itself, and if there are no clouds where you happen to be, you can go outside and see it now, because it's there, visible rather low down in the southwest. And if you know the bright star Vega and the square of Pegasus in the east and Altair in the Eagle, you can find Mars quite easily. In the Scorpion, not very far away from the bright red star Antares. But in fact, you can't confuse Mars with a star, because it is very much brighter, and of course it has got this strong red color. If you look at Mars through a moderate telescope, you can see these markings. And in briefly, I'd just like to show you 3 of the drawings that I made myself with my own 12.5-inch telescope earlier on this year. And over there on the right-hand picture, you can see again that V-shaped marking, which we call the Syrtis Major. Again here, north is at the top. Well, that marking is also shown on the Mariner pictures, and here again is one of those Mariner shots taken from a long way out, showing the 2 polar caps and the Syrtis Major. In fact, the markings of Mars, the dark ones, have always been something of an enigma. We know quite definitely that they're permanent, and you can draw maps of them. And in fact, I have got a Mercator map of Mars here, which I drew from my own observations. There again is the Syrtis Major, and Mariner 6 came down over this direction, over these so-called deserts. Well, the question is, of course, are these dark areas due to organic matter, vegetation if you like, or are they not? And what about those polar ice caps? Well, these also have been photographed from Mariner very nicely, and there again is the southern polar cap at the bottom, and you can see indications of the northern one at the top of the picture. And we've got some close-ups also of the southern cap, and there the jagged edge is quite clear. And the question is, are they due to some kind of icy or frosty deposit, or are they solid carbon dioxide? This is one of the things we hope that Mariner 6 and 7 are going to tell us. Well, those are the pictures, and I think you'll agree they are incredibly good. But to get the latest news about Mars and Mariner, I've just been in contact with Jet Propulsion Laboratory in California, and there I talked to Dr. Pickering, who is in fact in charge of the investigation. And I asked him about the latest news from Mariner, and in particular, what was the news about those strange, icy polar caps.
It appears as though the South Polar Cap, which photographs up very well in the pictures, does have a sharp edge on its northern boundary. And in fact, when we look at this in detail, we see that the sharp edge appears to be following the outlines of some craters. so that it must be on the ground and must be following the local topography. And on the other hand, the southern edge of this polar cap does not seem to go all the way to the pole. And this is very curious. I think it must be due to some sort of haze which is covering the actual pole. We hope that on Marinus 7 that we will get some close-up pictures of this area of the planet, so that we will know much more about it after the flyby on Monday evening.
What do you think is the cause of the polar caps? Water ice or frost or solid carbon dioxide?
Let's wait until we get a temperature reading, which I hope we will do on Monday. You know, we got some very good temperature readings with the infrared radiometer on the flyby last Wednesday night, but that was more or less along the equatorial part of the planet. This time we will be conducting a flyby which will reach right down to the polar regions.
What other things have you got of particular interest at the moment?
Well, the other things I think that are of interest are the ultraviolet data. This gives us some indications about the nature of the upper atmosphere, and the fact that we found no nitrogen, I think, is very interesting.
Very interesting indeed, and I think this question of the Martian atmosphere is all important. And of course, these pictures have come in, and already the experts are starting to discuss them. And I'm glad to say that we've got two of these experts here in the studio with us for this evening's Sky at Night. We've got Dr. Gilbert Fielder, and we're also delighted to welcome back Professor Samuel Talansky. And I'm going to ask Professor Talansky first what he thinks about these pictures, and in particular, what he thinks about the famous canals of Mars.
Well, I'm very particularly struck and intrigued at the fact that these pictures show a great similarity to the moon pictures. We see an enormous number of craters, and I think this ties up with a theory which is a sound theory in my opinion about how the moon and Mars both originated at the same time. This theory is this: the Earth is supposed to have spun round very fast like that, and in spinning bulged at the equator. Then when bulging, the bulging increased, and gradually instability set in, and the little neck developed something like an hourglass, and finally a huge piece, about a tenth of the weight of the Earth, was thrown off. This is Mars. A smaller piece, about 1% of the weight of the Earth, was thrown off in between. This is the moon. But at the same time, an awful lot of debris thrown around. Now, according to this theory, the moon, Mars, should have the same structure, the same density as Earth rock, and so they have. They're very similar. And it's probable that craters on the moon were due to this debris pitting the moon. At least a lot of the craters was due to this debris pitting the moon, and it's very likely that this similar debris pitted Mars.
So you think, in fact, that these craters on the moon and Mars were produced by a kind of bombardment?
A lot of them. A lot of them were, I think. There may have been some of them which were volcanic, but a lot of them were. And because of that, this is why I predicted that on the moon there would be little marbles. And I think there will be the same thing on Mars, only there won't be circular, there'll be pair drop because of the atmosphere.
Well, I don't think Dr. Fielder quite agrees with you on this one, so I'm going to call him in now. What do you think about it?
Well, of course, there must be impact craters on Mars. I think the point that I wish to make is that there may be more volcanic craters than people have been thinking. Mars is close to the asteroid belt, where it will get bombarded, more than the moon, of course, and there will therefore be more impact craters, one would expect, on Mars than there are on the moon. They may have been eroded out more quickly on Mars, however, because it has an atmosphere and water and so on, and dust. Well, if we look at some of the close-up pictures of Mars, this one here, for instance, shows a crater 24 miles in diameter, and it is not quite circular, you'll notice. It is slightly polygonal, and there are many of these linear features on Mars, ridges and troughs. The next picture will show a similar crater, and these linear features are characteristic of things produced internally by tectonic forces and possibly volcanism. We know this from the study of the moon, and therefore I think the evidence based on these polygonal craters and these linear features, these linear troughs and graben and ridges, is that there is at least some volcanism on Mars, and I would be inclined to say there's probably quite a lot.
What about this question of the canals being strings of craters?
Well, I don't believe there are canals. I never did believe there are canals. And it's my view is that in the past, people with insufficient resolving power have seen chains of craters due probably to the to meteors coming in along trajectories which are fairly common, and a chain of craters, a line of craters which you did not separate, would look like a line. And as to why this changed in color, I think that's merely sandstorms. There is an atmosphere, there is probably a sandy surface, And at different times of the year, sandstorms would change the colour of the surface.
Now, what about this all-important question of life on Mars? Do you think that these dark areas are due to anything organic? What do you think about it, Dr. Fielder?
Well, I think the question is still to be resolved by use principally of spectrometers, which are carried, particularly the infrared spectrometer and the ultraviolet spectrometer on board Mariner 6, which will look for bands in the infrared part of the spectrum which are known to be characteristic of organic molecules, or plant life, if you like. If these bands are found to be sharp and in the right places, then by comparison with vegetation on Earth, we will know that there is vegetation on the surface of Mars.
What do you think about that?
Well, primitive life there may be. I don't even think so. Intelligent life, certainly not.
So, in other words, you rather think that Mars is a dead planet?
Absolutely dead as a dodo.
Well, I suppose one of these things we're going to find out fairly soon. Well, another person whom we asked about this was Professor Sir Bernard Lovell. And we went up to his home in Cheshire and we asked him what he thought were the most striking features of these pictures of Mars sent back by Mariner 6.
Well, the most obvious feature of these Mariner photographs is, of course, the craters which we see. And the surprising thing to me is not that there are so many of them, but there aren't a lot more. You see, Mars is much closer to the asteroid belt than the Earth and the Moon, and calculations indicate that the rate of impact of asteroids on Mars is going to be about 20, or has been, 20 or 25 times greater than that on the Earth and the Moon. Well, now on Earth, why aren't we full of craters like this? The answer is a very simple one, that over a few thousand million years of our evolution, they've largely been weathered out and are now lakes or such things. On the Moon, we still see them. Now, on Mars, the situation is intermediate. Mars has an atmosphere. At the surface of Mars, the pressure is only a tenth of that on Earth, but at a height of about 20 miles, the atmospheric density is about the same. And on the whole, one would have expected, I think, to see at least the rather more craters than one sees on the Moon. Therefore, I suspect that these features of Mars, which we're now seeing, are rather young. By that I mean perhaps less than 1,000 million years. If this turns out to be the case, then the situation is extremely interesting, because it will give us important clues as to the changes which have occurred since Mars was formed from the primeval material. Biologically, I don't think the situation has been changed very much by these photographs. There must still be intense interest and importance attached to the future of biological investigations. You see, it's extremely likely that the planets Earth, Mars and Venus began their development in roughly the same form, and in the beginning at least had the same type of atmosphere, but because of the differences in mass and temperature, because of their different distances from the sun, there have been these vastly different atmospheres developed, where we have large amounts of CO, carbon dioxide, both on Mars and Venus, and which are now not very favorable to life. Nevertheless, it would be extremely important to investigate the existence of any primeval life forms.
Of course, we haven't yet got the full story, and in particular, we await the results of Mariner 7, which is going to pass over the Martian pole. But already we've learned much more about Mars than we've ever known before. And I think now, in a few weeks at least, we ought to have an answer to that age-old question: is Mars a dead world, or is it a world where there are things which live and grow? Good night.